All right, guys, we got a somewhat quick and easy one for you today. I'm gonna try and keep it short and concise. We've talked about how to build towers for years on this channel, 10 years now. We did a video that's actually gone quite viral and gotten over 10 million views now, which is what to do after you build your tower, which is how to get your drivers installed, your operating system, chipset drivers, BIOS, software installed, all that sort of stuff. But we're gonna go ahead and continue on now from that, which is now showing you how to stress test /test and make sure all your components are working exactly as they should. NZXT's build is a quick and easy way to get a new gaming computer, and right now they're proud to announce expansion and availability to Australia, the Netherlands, France, and Italy. Build a gaming PC on your budget using the built-in configurator and see exactly how your favorite games will perform. Want to build your own PC but still have the NZXT Peace of Mind warranty? Then the new BLD Build It Yourself kit has what you want. Buy it and build it yourself, and NZXT has you covered. To get started configuring or building your next gaming PC, visit the build link in the description below. All right, so we're assuming that you've already built your computer and you've already followed our tutorial on how to get your OS installed and all the software and stuff ready to go. So when it comes to stress testing your stuff, a lot of people think you only have to do stress test if you have overclock supplied or something custom, but that's not true. This is actually a really good way to test to make sure your thermal paste is properly applied, because your cooler can often, the temps will look totally normal as you're operating the computer and browsing around and stuff, but you start gaming or you start maybe trying to live stream, put a little bit of stress on the CPU, and suddenly you start getting the blue screens or the crash to desktops or the hard locks where your mouse stops moving and the only way you can get your system back is to flip the power switch on the back of the power supply and get the system to come back. A lot of these types of issues could be due to excessive heat, where maybe your thermal paste, or you forgot to put the thermal paste on entirely. Believe it or not, your system will operate normally with the heatsink touching the top of the IHS on the CPU without thermal paste until it's under load. Then you'll notice things start to act really weird. So it's just good practice and good rule of thumb to just stress test everything under unrealistic scenarios, like for instance, Cinebench. Now, when it comes to testing CPUs, it doesn't matter if it's Intel, it doesn't matter if it's AMD. Cinebench is a test we like to run because it gives us the worst case scenario when it comes to heat. So that's why the very first thing I will do is I will always go to Cinebench and start running a test on that, which is a loop, because we want that heat to generate. Two things to keep in mind before we do this. One, if you're running an air cooler, it will take a very short amount of time for the CPU to reach its maximum temperature equilibrium. Equilibrium means where the cooler is fully saturated, it is working 100% of its capabilities. Water, on the other hand, whether it be a custom loop or an AIO, takes much longer for the thermal capacity of the liquid to be maximized, which will then give you your equilibrium. Typically, it's about 30 minutes before you will actually max out your temperatures on AIOs. Custom water loops can take even longer if you have a large capacity. So don't put a 2-minute test together and say, hey, my temps look great. And then suddenly you go and you start doing long rendering sessions or long live encoding sessions, and then suddenly you start noticing weird things happen because if something is less than desirable on your system, and it starts to heat up over time and it continues to heat up, and then you start getting into that throttle territory and things start slowing down, that could be because something's up with your cooling system and you didn't test it long enough to actually expose that particular problem. But you need a way to monitor your temperatures and your core clocks. Now we're using Ryzen, which means that we can actually use Ryzen Master to keep an eye on our temperatures and our clocks. I do have PBO, or Precision Boost Overdrive, activated on this CPU. Precision Boost Overdrive is an automatic overclock of the processor. Now Ryzen Master allows us to see right here our temperature. The top number that's fluctuating is our current temp. The number at the bottom is going to be whatever the TJ max, or the thermal junction max, of your CPU is. That is the hottest point of the CPU, how loud? Yeah, loud technically, because fans and stuff. How hot it's allowed to go before it starts to slow down the clocks to control its temperatures. If the temperatures get out of control, the clocks continue to go lower and lower and lower and lower until it finally determines, hey, we are completely overheating, we're in meltdown mode, where the system will then shut down. If you start to see and get anywhere near 95C, then you definitely know that you have a problem with your cooler, your fan setup, your thermal paste, something. Even a stock Wraith cooler or something on here would be able to take a PBO, or Precision Boost Overdrive, and still keep it underneath its TJ max. We're using a Dark Rock 4 here, which is not gonna get us anywhere near that because it's a much bigger cooler than we need with this CPU. Now the other thing too is you will be able to see right here the peak speed. This is obviously our core clocks right here. Right down here underneath where it shows the CCX or CCD0, This is our current speed. If you're running an Intel CPU, you'll want to download a utility called XTU, or Extreme Tuning Utility. That is an actual piece of Intel software that will communicate directly with your CPU. It will show you your current clock speeds. It'll show you your status of the CPU. Is it throttling? Everything you see here in Ryzen Master is going to be available also on Intel's XTU. So you'll want to take the logic we're applying to our testing and just use XTU for Intel or Ryzen Master for AMD. The other thing we want to test here is, what is our power setting set to? Now we are out of the box dock settings here. So I just went to start, I typed power, went to power settings, go to additional power settings. We are set to balanced. Down here under additional would be high performance. I'm leaving it balanced. This is a gaming machine. We don't need it to run full speed all the time. We want it to fluctuate. That way temps stay down, power draw stays down until it's needed, then everything comes back up. So you can set your testing here. 10 minutes test for throttling, 30 minutes is test for stability. So it even tells you here. Now, Cinebench is only one utility. It's only one type of instruction. It's only one program, and it's not going to give you the full indicator of the stability of your system. I've found though, typically, if we can run Cinebench without a problem for the 30-minute test, we can run pretty much anything without a problem. I find this to be the most demanding test, but there have been times we've gotten overclock to be stable in Cinebench, and then suddenly you go into Premiere and funky things start happening. It has everything to do with the way the CPU is accessed. And the other thing too, is when Cinebench fully loads the CPU's clock speeds will kind of drop a little bit because of power limits and all that sort of stuff, which brings the clock speeds down. Whereas other programs that are not as demanding might allow the clock speed to stay up a little higher, where it kind of fluctuates up there. And it's some of those fluctuations between, say, 5 gigs, 5.2, 5.1, 5.2, where you start to notice instabilities. Whereas when it drops down to like 4.8 or 4.9 all core on like an Intel CPU, they're actually more stable because the clock speeds aren't as high. So you're gonna want to really test this out in your programs you're expecting to use the CPU in before you start doing critical tasks like actual work or rendering for jobs or whatever. Before you start to say, okay, I'm fully stable, you might lose a lot of time with work by losing data and stuff because of crashes. So with that out of the way, make sure you have your system set or your test set to your minimum duration. 10 minutes is fine for an air cooler. And we're gonna run multi-core because single core is only gonna give us the single core performance. Multi-core is going to show us the stability. So once you hit start, it's going to take a minute for it to start going, and you'll notice the temperature starts climbing on the CPU before the test ever starts running. But as we can see right now, we're running at 4.625 gigahertz. We're only hitting 6970 C. So if we do the math, 95 minus 70, we've got 25 degrees Celsius of headroom right now before we would even start to throttle. But what we're looking for here is our temperatures and our clock speeds. Because our temperatures are so low and so far below our limit, we are maintaining our full boost clocks with our PBO Precision Boost Overdrive. What we want to see is if this number starts to drop, we immediately would want to look at the temperatures. Typically that number comes down if the temps are too high, if you have an overclock enabled, which is lifting all those power limits. But already I can tell you right now, with an air cooler, what the temps currently are, and you can see they're not really climbing, and we've gone up what? Not even 2C since we started the test. You'll notice these temps now, I could let it run for a half hour and it'd probably never go any higher than 73. That's typically what you'll find with an air cooler. Like I said, water cooling, let it run for the full 10 minutes, let it go for 30 if you have the time. That will give you the true indicator of your test. All right, so I'm pretty convinced that we're fully stable here. Our temperatures are still at 73.2, 73.4, 71.8. So our temps are fine. Our clock's exactly where they're supposed to be, 4.6 gigahertz. I just want to go ahead and stop this test right now because I want to show you what it would look like in a stock situation if we did not have Precision Boost Overdrive. Now, if I run this same test, we're going to notice two things. The temps are going to be much, much lower, but look at our PPT, it's maxed out. This is saying we are using 100% of these 76 watts available to us. Our clock speeds have dropped all the way down to 4.15 gigahertz all core. That's specifically because of the power limit. So this is one of the reasons why I enabled Precision Boost Overdrive on AMD CPUs. In fact, I can even hit apply on that while we're running the test. And now you can see it jumped right back up to 4.6, back up to the 71 to 73 C, and then all these power limits have been lifted. They're just an arbitrary number. There has to be a limit. Unlimited is not a mathematical factor. So it has to put a number in there. So could you imagine a 540 amp draw CPU? So what I would do next, if I was testing this for full stability, is I would take some sort of a project, a Premiere project or something, and I would create an encoding timeline that's designed to be stressful. Lots of transparencies, lots of overlays, lots of transitions, and then maybe take the timeline and duplicate it a bunch to where I'm trying to make the render take a long time, 30, 40 minute render, then I would do a Premiere render and see if it passes. And maybe do that a couple of times. If it does, then typically we're good enough to call our CPU ready to work. Let's go ahead and call this CPU good, and let's move on to the GPU. The GPU is the other thing where if you're applying overclocks, which we're not in this instance, you would start to notice issues nearly right away when it comes to your GPU. So I'm gonna use Heaven for this. It's a benchmark, but it's a looping benchmark. Now we're gonna be running this in Tessellation Extreme, anti-aliasing 8x. We're not gonna go full screen. We're gonna go 2560 by 1440, even though this is a 4K panel. And then we are gonna be running a preset custom because of everything we just added, which is custom. We are running AMD Radeon software. If you were gonna be using an NVIDIA graphics card, GeForce Experience has telemetry built into it now, so you can see the temperatures and the core clocks and all that sort of stuff. And we are going to use the default overclock GPU. That's a it's a 1 bar overclock so that you can basically allow the logic of the graphics card to overclock itself slightly. And I'm gonna start there. I wanna see what it does. That's why I run this in non-full screen. I run it in windowed mode, so it will still go full speed in the background, but I can have an overlay going right here. But our current clock speed went up to 2665. Yes, AMD does have a superior clock speed to NVIDIA. However, NVIDIA still has a superior instructions per clock than AMD. So it's kind of funny how that balances out. All right, so AMD's smartass memory is enabled by default because it's an AMD motherboard, and by the latest BIOS with smart access memory, it's on by default. But what I'm looking for here, a couple things. Clock speed, I'm looking for major fluctuations. Will that start to drop? If that's starting to drop, then we're gonna see problems probably with thermals on our GPU. I'm also looking for what our current temp and our junction temperature are. Now, current temp and junction temp, these are two very different things. Basically, current temp can be looked at as an edge temp, or the lower temperature cores of the GPU. Now, there's temperature dies all over the GPU. Memory temp, VRM temp, edge temp, junction temp, memory temp. There's all sorts of temperatures. But what this is giving us here is our range, our coolest temperature reading on the GPU die, and then the junction temperature is our hottest. So what we're looking for here is what is that spread? Now that spread on this particular GPU is fairly low. Our current temp is 50C, our hottest core or hottest spot on the die is running at 65C. That is really cool. Absolutely no issue whatsoever. It drops in between scenes, as you can see right there. It went from 2666 down to like 10 something and it jumps back up. Heaven, in between scenes, reloads another scene. So typically if you're gonna find a crash with Heaven, it's gonna happen in between the scenes, where the screen goes black, and as the new scene comes on, then you'll see a crash because that's where you get that sudden spike in frequency, and it's those spikes that are gonna basically expose any sort of a stability issue in your system. It's not necessarily the constant load that causes a crash, it's when the load is lifted and then suddenly the megahertz jump up real quick. That's typically where you'll find any sort of an issue there. But what I'll do now is I'll let a test like this run for, when we do some of our stability testing here with overclocks, we've let it run for hours. But what I will do, once I determine Heaven has stress tested it enough to determine it's Heaven stable, then you can move on to something else, whether it be a game. Like I said, 3D Mark. 3D Mark's not free, but 3D Mark does have a stability test built in where it will take a 3D Mark test and it will loop it. If you pass that, you can pretty much always guarantee you're gonna be stable. Out of the box stability test very rarely yields any sort of instability problem with the stuff. Usually if any sort of crash happens in this scenario we just tested within, it means we either have a bad installation of our cooler for the CPU, or the CPU/GPU themselves have some sort of a defect in them. And if you start finding where stock settings are crashing, that's an indicator something is bad with the product itself, whether it be they forgot to put thermal pads maybe on a VRM, or thermal pads on the memory, or bad application of GPU paste. Yeah, we've seen it before. We've seen bad applications of GPU paste where a whole piece of the die is not touched at all by thermal paste. That's the kind of stuff that can indicate and be shown by these basic tests that we're doing. All right, so the last we're gonna test here is our memory. You'd be surprised how most of the time people message me and say, hey, I'm getting this really weird issue and these crashes and stuff. Is there something wrong with my memory? You can test that. There's actually a free utility called memtest x86. And what this is, it's a software that will run on an external source or a USB stick. So I'm not gonna show you guys how to install it and stuff. You guys can go and find videos on that. It's pretty simple. So I'm gonna go ahead and put in the memory stick. We are gonna reboot to this drive, and then it will give us, it will start our mem test. And what that's gonna do is it's gonna test every single sector and chip on that memory. Now to get into your memory, or to your USB stick, every single motherboard is a little bit different on how the boot overrides work. So you're gonna have to refer to your BIOS and your particular motherboard to determine the best way to get into that bootable media. You might have to go in and change your priorities. You might have to go into BIOS and then do a one-time boot override. And the NZXT board, it's hit F11. For us, it's a Corsair Voyager, that's a 32 gig stick right there, partition 1. Now it's booting up memtest, and what's gonna happen is it will automatically, once it tests everything, it's going, what is your RAM? What's your RAM's controller? Oh, this is what you've got. This is what's expected to work, and this is how it's expected to run. So it's gonna start automatically in 6 seconds once it starts. It's now checking every single bit and byte and but, they're all the B's of those memory sticks individually to determine if everything's running properly. If this passes, we can pretty much guarantee that our memory is fine. Now I am running the XMP profile, or the DOCP for AMD. We are running the extreme memory profiles. Remember, memory by default does not run at the advertised speed. You have to go into your motherboard and you have to enable either the XMP or the DOCP to get the advertised speeds of your stick. I get people all the time, I even got one yesterday. Something's wrong with my memory. It's supposed to be running 3600, it's only running 2133, help, and all these exclamation points. And it's like, I talk about this every time we build a system, but it still surprises me that the memory manufacturers don't put even anywhere listed on their memory, like put some sort of a slip of paper that says, warning, must enable these speeds for these speeds. Like, they don't tell you anywhere that that's the way that it works. They just expect people to know. And unfortunately, people who are doing this for the first, second, or even fifth time don't always know. But anyway, it's gonna tell you what it's doing on the different tests. So right now we're in test 6, block move, 64-byte block. So it's taking chunks of memory and moving it and rewriting it. And this is the way that it tests. It will do it in random patterns, it will do it in actual patterns, it will do it in random sizes, small size, big size. So it's just taking chunks of information, it's moving it all over the place until all of the bytes have been tested on the RAM. All right, so 26 minutes later, we are on pass 2. No errors were found. So as it accumulates and does all these different tests, the hammer test, the sleep test, it'll go to sleep, wake it back up with a big load, and then go back to sleep, whatever. Sounds like I'm describing something, but anyway, I digress. It's gonna do it 4 times. Now, we don't have 100 minutes right now to spend on this, but if you wanna be completely thorough with your test, you would just walk away and let it go and do its thing, and if any errors are found, well, that's bad news. More often than not, you're not gonna find any sort of errors here. So I'm going to actually just go ahead and exit this test. And you can configure this to let it go just 1 pass. 1 pass is usually good enough, but 4 passes would be the ultimate test. Now, the more memory you have, the longer it's gonna take. So now that we've done all this PC is now ready to be given to Joe for his birthday. And I have confidence that it won't have any sort of weird issues that haven't already been, discovered and fixed. So with that, guys, thanks for watching. I hope this video's helped you feel a little bit more confident with building your first computer and making sure it all works properly. Share this video with someone maybe that's talking about their computer acting weird or weird stability issues, and usually by doing these tests, they can figure out what the issue is. Thanks for watching, guys, and of course, we'll see you tomorrow.
We'll be back in 5 years.